Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Okay, guys, so please focus on my screen. So let's continue the discussions what we were doing till last day. So now we figure it out what we have in the master. Master, we have a 4 component. We understood. I assume we understood well. API server, cluster stored powered by etcd, controller manager, scheduler. We also understood what we have in the node. Node, we have a 3 important component: kubelet, docker, and kube proxy. We understood also, and that is node has pod, node has multiple pod. One pod you may have one container, or one pod you have a multiple container. We also understand pod get IP address from the kube proxy, and the same IP address shared by all the containers of that particular pod. So these are the things which we have learned, and apart from many things. Now the time has come to focus on the last component, and which is workstation. Downside, which you can see that in the workstation, I see that I have one utility, one tool, and the name of the tool is kubectl. That's a tool I need to install it, so of course I will install it. That's not a problem. But the most important thing is I need to write one deployment package, and that deployment package, it has to be JSON or YAML. But mind it here, if you're writing in YAML or JSON, that's not a problem. But API server always accept in format with which one? Which one?
JSON format.
JSON.
JSON. Yeah. So if for your, because YAML is compared to JSON is easy to write. So even though if you write in the YAML format, kubectl will convert into JSON format and then send it to API server. So remember that one. So API server, it's always good format is JSON format. For us, for the human, it's a good format is YAML format. But converting of YAML and JSON is just not a matter of second even. Okay, it's a very lightweight and very fast. Okay, so kubectl will do that. Kubectl will talk to API server. Remember, kubectl will talk to API server, the package which you have written in JSON and YAML. So now the most important question what I'm having right now in my mind is that what you have in JSON file or what you have in the YAML file. That is important. So guys, have this question mark in your mind memory. What is there in the JSON file? What is there in the YAML file? So if you have that question in your mind, then now we should start understanding this. So guys, first thing we need to understand declarative model. Declarative model. Okay, so declarative model. What is a declarative model? So guys, if you look at the evolution of programming languages, okay, So initially when we got the programming languages, we got we got compiled languages. Okay, compiled languages. Compiled languages such as C, C++, and Java. But writing a software, testing a software, delivering the software, running the software in those technology used to be very time consuming. Software development used to take longer time. Then over the period of time, we got interpreted languages. Interpreted languages means Perl, Python, you know, PHP. These are the interpreted languages. That means you don't have to compile it directly. It will, you just have a program, it will or directly run it. So that way the software development process has become faster and faster. And then we got the internet, and we got the internet. So guys, what has happened with the internet availability? Everyone started thinking about, why should we write all the functionality for each software? There are millions of software which is available in the whole world. You know that. I don't know the number exact, but I'm just guessing it. Okay, millions of software. Every company, every organization, every country, every state have their own kind of software. Every organization own kind of software written. But if you look at this, in each software, functionalities are common. Like JavaScript validation is common across all the software. Login page is common, registration page is common. Like that, I'm just trying to help you to understand that. So that people started realizing that why we are reinventing the wheel again and again for each software. Why can't we do one thing? Let's write the one code which should be the best code, well tested code, and then use the same code, reuse the same code rather than rewriting and stuff like that. That is where that from the programming language, the framework concept has arrived. So in the framework, you don't have to write the software too many things. Most of the pre-built functionality, you get it, reuse it, and continue developing your software. So now over the period of time, guys, now because of the software availability is too much, all kind of software is available, but some of these are like you can embed in your code. Some of the software you can use it through the APIs also. Okay, so when it comes for API based software which is already available, then instead of you writing a code, mind it here, instead of you writing a code, we started to declare about the what you want. See here, functionality is already available. Okay, functionality is already available through API. Just you need to declare what do you want. Declare. And which are the declarative languages which we got very popular? Initially we had XML, now we got JSON and YAML. So now from the compiled to interpreted, interpreted to declarative languages, we got it. So in the declarative languages, what we do, we just declare it. Okay, we declare it and send that file to the APIs, and API is doing the work for us. We are not doing anything. We are not writing a code. We are declaring it. But the question is, what you are declaring it. So guys, you are declaring a desire. What is desire? What you want. What you want. Declare your desire in the YAML or JSON and send that declaration to the API server, any API server. For in this case, you have a API server in Kubernetes master, and then they will understand your desire, store it, and then act on it. You don't have to do anything. No complicated programming languages you need to write at this moment. So that's called declarative model and your desired state. You First know what is your desire, then you declare, and then deploy it in the API server, send it to the API server. Are you understanding it, guys? What do you need to do in this Kubernetes? All of you?
Yes.
Yes, sir.
Yeah.
So guys, no programming languages you have tried, just declare it, your desire. It's very simple. So the most important thing which you need to know, what to desire, what is my desire, what I can expect from the Kubernetes. So I'll teach you that one. That's the most important question. So guys, if I go further, see here, we declare in YAML or JSON our desired describe state, whatever I wanted, put it in that, send it to the API server, and then after that, what happens? We know that. What do you want? 3 pod of what? Nginx. Remember, pod has a container, so you have to tell Nginx. So I want 3 pod of Nginx. The moment you send your desire, I want 3 pod of Nginx, you got the 3 pod. How you got it? I think you know that, but still I will repeat one more time. You have a desire of I want 3 pod in my cluster of Nginx. You declare at the YAML or JSON, you send it to the API server. API server stored that in the KB store, which is etcd. Okay, controller manager reported saying that, okay, in my cluster you have a 0 pod of Nginx. So API server calculated all this thing, the data which you have in a database, which is a desire, and the reporting by controller manager, which is actual reported by controller manager, controllers. So now if there is a mismatch, API server will say, okay, I want 3 pod to be created. That request sent to the scheduler. Now scheduler will decide anti-affinity, affinity, those are the things we have it, constant and stuff like that. So, but I'm not complicating here. Scheduler will decide which node, which pod to be scheduled to. And in the node, now you have what? Kubelet, which is a minion, remember? Which instantiate a pod and request the Docker to fill the container, and the request kube proxy to give the IP address. And you got the 3 pod. Did you understand that all how it happens?
Rajesh, one question here. What's the role of KV? Can you repeat that again? The etcd?
etcd is a KB store, no, cluster store, where the persistent storage happen. Anything which comes from outside and inside gets stored in the cluster. I
So
mean
the
KB
request
store.
which has come, to API server will get stored in etcd.
Everything, whatever you request and whatever the state of the clusters, everything is stored in the etcd. That's the only one storage which you have.
How will this
Got it?
information get used? So let's say I have saved this information that I want 3 pods of Nginx. Now, what's the benefit of storing it? Where will it get used?
Okay, I will put it in this way. Sir, I ask you, I need, think simple. I asked you, I need 5 mobile in your home. I asked 5 mobile. So it gone, you hear from your ear, it gone to your mind stored it. What this guy wants? 5 mobile, but where? In my home. So what you will do? First your eyes will check how many mobile already exist in my home. Maybe 2. So how many missing? 3. So then you will take actions on 3, right? So
Correct.
all this actual and desire has to be stored here, stored somewhere to do the manipulations, right? Correct?
Okay.
Getting points. So this, whatever I requested 5, if you are not storing somewhere, then how do you make sure that you should be having always 5? Are you getting my points?
Yeah.
You have to store in your memory. Let's say if I tell you something, I need 5 mobile, and you never stored, then you don't know anything. You don't know about the mobile, you don't know about my desire, what I wanted. Correct? If you want to know my desire, then you have to store in this statement in your memory, right? That is where
Correct. So is there any? Yeah. So is there any communication happens between this etcd and controller?
No. I think we discussed in detail yesterday.
Correct.
No one talk to no one except API server to etcd. Controller talk to API server, scheduler talk to API server, kubelet talk to API server, kubectl talk to API server, kubeproxy talk to API server. Any external and internal communications, only one front end is API server. Please understand this.
Okay. So this information
And
gets saved and then API server use this information to talk to controller then.
yeah, API server is the only who can talk to etcd, and they communicate etcd for fetching the information what you have desire, what you have actual, and based on that they can take up a call.
Okay.
So,
Okay, so guys, yeah,
just a thought here. I understand that API server is the front end, but if the controller manager is the one who is actually deciding, then why not the desired ask connect with controller manager than API server architecture wise? I'm asking. And was there a specific reason that API server is front ending, not control manager for the request? Because control manager can manage the request straightforward, right? Why to go through this layer?
control manager request for what? I didn't get you.
So I'm saying the control manager is the one actually who is sending what pods to be created, what not, right?
No, you completely
How is
misunderstood.
he?
Controller manager is just a controlling. It's in simple way, controller manager has multiple controller, and each controller just monitor something. For example, let's say one I'm just giving you a very dumb example. Controller manager has one of the controller which is CPU. So CPU will monitor each node CPU, how much CPU, how much CPU, how much CPU. This runs in the loop. Controller manager one real controller which is node controller. That controller will keep monitoring node is up, 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 running in the infinite loop. The moment some node is not up, it's not responded to the controller, then immediately controller will respond to API server saying that okay, this node is not responding, please throw them out of this cluster. So it's like that. So controller manager is different, I think.
So it's a more of a utility to the API server, right? A helper, I would say. That way.
Okay, so I am feeling like you missed the whole session of yesterday, I guess.
No,
Did you?
I attended fully. I'm just
Okay.
trying to deep
Yeah.
dive there on the controller manager side, because that yesterday you did speak, but yeah, probably my understanding is.
Yeah,
I think
so here again I'm
Nishant, in my view, I see master is a distributed system, right? So when you say can the controller or somebody else, some piece of software take the information, execute, I think there are two parts. One is that you ask the API server for 3 pods of engine X, it is most, right? So after some time, if one pod, it still needs to know. So it's not about just managing that one case. And second is distributed. There can be multiple masters. You can add more masters. So if the information is with one piece of software, how do you distribute the information? So all of the information will be stored in a persistent distributed store, and then different distributed components can come and act upon that information. So the controller will notify probably that there is something it's a change from there's a deviation from the desired state, and then some kubelet on some node can come and pick up that and execute, and then it can come back and report saying I have started one pod, and so the state is changed again, so the next one. So all of this is so distributed that you cannot have information in a piece of software, because a piece of software runs somewhere. So information has to be in a distributed store that everybody will act upon. I think that is why the architecture is like this.
yeah. So
Okay.
if I sum up, then you are managing this master component is managing the entire cluster. The clusters, you may have hundreds of machines, and many components talk to masters. Many component means hundreds of node talk to the master, and we are also talking to the master. So for that sake, For all this communication sec input and output, they have made it only one gateway. You can say something like that. Registry, I say API server. Through API server, everything get delivered to the cluster and everything is received into the cluster. But everything, whatever you send and whatever you receive is being stored in the etcd. But what is happening in my cluster? See here, if I say in a simple way, in the etcd kb store, you have a actual state of cluster and you have a desire state of cluster. Desire means desire from human and actual means in reality. So desire, we send it, we human send it through the kubectl, remember, through workstation. But who will send me actual? So actual state of the cluster is sent by controller manager to API server, and API server stored that in the cluster store. So this is all the game of actual versus desire. Okay, if actual and desire is having some mismatch, then that will be taken care by scheduler based upon the request of API server. Scheduler will either will ask, let's say if let's say I want 5 pod. Okay, so the 6 pod is there of that particular name. So API server will ask terminate 1 pod. Scheduler will go terminate. Scheduler will request to terminate some node, some pod, or there is a 5 pod I want it, but only 2 pod is running because of some node problem. Earlier it was running 5 pod, but now it's running 2 pod because of some problem. So now 3 pod is missing. So now API server got to know there is a 3 pod is there, 2 pod is missing. So let's create a 2 pod remaining by requesting the scheduler to schedule this work to the any available node. So this way, if we understand, probably we'll get better shape actually. Are you understanding it?
Yeah, much clear. Yeah, thank you.
Okay, so guys, here we have a 3 node. I declare where YAML or JSON. I want 3 pod of what? Nginx. I send to API server and then forget about it. How it works, we have spent get hell lot of time on that. So we got the 3 pod. Suddenly what happened? One node is gone. One node is gone because of n number of reasons: networking reason, hardware issues, software issue, this issue, that issues, I don't know. So actual is 2, desire was 3, is mismatched. Now again, controller manager will say I got a 2, API server will check I have a 3 desire. So same time API server will request scheduler to schedule third one. Got the third one. Actual is missing, actual and desire is matching. And who's doing all of this work? Not you. Not you. You are sleeping at 3 a.m. This has happened 4 a.m. or 3 a.m. Not you. Kubernetes have run it. That's the reason we call it Kubernetes manages your desire state. Okay, so guys, so most important point here is overall, most important point here is now from last day I am talking about pod. We don't know about the pod, but at least now we know that pod contains container and we want the pod to be created. Okay, so guys, what is your job in the Kubernetes? Because I've been telling you everything will be done by Kubernetes. Then what you're going to do? So guys, you are going to know what to desire. Please hear me out. You are going to know what to desire. That's all. What you want? Do you want pod? Put it in YAML. Do you want controllers? Put it in YAML. Do you want services? Put it in YAML. Do you want storage? Put it in YAML. Do you want security? Put it in YAML. Do you want load balancing? Put it in YAML. Do you want anything? Put it in YAML. So your job is just to learn these Kubernetes API objects. Yes. What do you want? That's all you have to learn. If you learn this, what is pod, what is controller, what is services, what is storage, what is security, what is this, what is that, that's all. Put it in YAML and get it done by the Kubernetes, nothing else. So guys, this is not an exhaustive list. We have a more than 54 APIs which you need to know, to know the what to desire in YAML or JSON. Are you getting my points, guys? Are you getting my points? All of you?
Yes. Yes, Rajesh.
Simple. So everything is set in the Kubernetes. Master is running, node is running, everything you have at workstation, you set it up, but you need to know what to write in YAML. That's all. No work is there. That's the reason I said, guys, if you understand the discussion, you understand the today's and tomorrow, because Kubernetes just works. Remember, hide complexity, avoid create abstractions. Everything complexity is hidden within a Kubernetes, but it works if you have a right YAML or JSON. So with that, now let's get started. What is pod? Yes, now we are learning what is pod. Okay, so guys, please understand what is pod. So guys, again I will repeat for some of you if you have missed that some of the part of the yesterday's session. What is pod? So guys, so far I didn't know about the pod, but I know the pod. See here, what are the knowledge you have about the pod? Let me tell you. I sense that the pod is requested by us and then scheduled by scheduler to kubelet in the worker. Kubelet instantiate a pod in the worker. Please hear me out clearly. Worker. Pod get IP address from kube proxy. Pod have one container, may have a multiple container. In the one worker, you may have a multiple pod also. Okay. So these are the things I learned actually throughout the discussion. But now we will formalize our learning process about the pod. So guys, understand in a simple way. Guys, when you use a hypervisor like a VMware, so guys, what do you create? Tell me. What do you create?
VMs specific operating system.
Can you create from the can you create from the VMware container?
No.
Great. You must be laughing on me why I'm asking stupid question. So guys, same way, think simple. VMware can create a VM. What is a VM? I think you know that because you are using from last 20 years. But let's say if you want the container, then you will go to ask to VMware or Docker. Whom you'll ask? Docker. So guys, VMware don't understand container, Docker don't understand the VM. Everyone has their different wrapper around it, their resources around it. So you know what is container in detail, we discuss about that. So I'm not going to discuss, but yeah, VMware manage VM, Docker manage container. So Kubernetes, can it manage the container? No. Kubernetes has no capability to manage a container. Kubernetes do not want to manage a container. Remember, Kubernetes is not a container runtime environment. Kubernetes is orchestrator for container at the large set of machines in a cluster. So guys, what Kubernetes has done, Kubernetes cannot manage the container directly, but what Kubernetes has done, Kubernetes can manage a pod. So now you have to come out of the container world and get into the pod world when you are in operation. Pod. When you want to say you run application, okay, this pod, that pod, this pod, that pod.
To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
Simple rule, guys. VMware create a VM, Docker create container, Kubernetes create a pod, instantiate a pod, manage the pod. Okay. So now, guys, let me ask you one more question. So when you create a VM contains what? Tell me. VM contains what?
Boot file system.
Yes, you got it.
Network,
Can I call it
secret.
operating system in short?
Yeah.
Can I call it
Yeah.
operating system? So guys, VM
Yes.
contains operating system, but container contains what? Tell me.
Root
Everything
files.
other than root system.
Root file
Network,
system,
PID.
right?
Yeah.
Yeah. PID, network, user, and mount. Root file system, right? Container, the one which you see, experience it. Root file system, right? Not a boot file system. So guys, here VMware contain operating system, container contain root file system, pod contains container. Simple. Okay. Now third statement, guys. When a VM is running, tell me, virtual machine when it is running, when a condition, tell me. When VM is running,
When it is powered on.
powered on, but of course, but you know the formula. I think you should not forget that formula. I stress so much on that. What was the formula rule of runtime environment? I know that you probably know that if I give you the pointer, but I want you to recall it. When VM is running, okay,
Process is running.
which process?
Hypervisor is there.
No. Okay, when
PS0.
container is running, tell me when container is running.
When PS1 is running, the first process.
When PID1 is running.
PID1. Remember, guys, very simple concept I have stated first day or second day. I don't remember though. VM is running as long as your PID1 is running. Container is running as long as the PID1 is running. The difference between the container and VM is in the VM, always PID1 is your system D because of the boot file system. In a container, your PID1 can be anything which we have learned actually. So now the question is, what when the pod is running, guys, pod is running as long as the container is running. Pod is running as long as containers are running. Okay, understand that. It's a very simple statement I'm making. So in a nutshell, what is a pod, guys? The same way VMware manages the VM, Docker manages the container. So same way Kubernetes manages the pod. Same way the VM contains the operating system, container contains the root file system, pod contains the container. Same way the VM is running because the PID1 is running. Same way the container is running because the PID1 is running. Same way the pod is running because of the containers or containers is running. Okay, so what is a pod? Pod is atomic unit of scheduling of runtime environment in the Kubernetes. Simple. Kubernetes means pod. Pod means Kubernetes. Did you understand that now? What is a pod? All of you? Guys?
Yes, Rajesh.
If not, let's understand more. So guys, containers always run inside a pod. Pods can have multiple containers. What happens when you have a container inside a pod? Any resources we associate with the pod, such as network, IPC, mount, anything, all container can access. All container can access the pod resources. Okay. When you have a pod with a two container, this is called tight coupling. When you have a pod with a one container, this is called loose coupling. When, see here, there is a pod, one pod with one container Nginx, left side, and right side one pod with a 5 Nginx container. So 5 Nginx container is wrong. One Nginx is right. Why is that so? Anyone has a clue on it? Anyone has a clue on it?
Yeah, if goes down, then there are other pods to manage with. But in this case, tight coupling, one pod goes down, all containers are within that pod only.
Yeah. Any other perspective would like to share with me? Think about it.
If you just want one more container or pod for nginx, it's not possible in the right scenario.
Yeah. So see here. See guys, you have only one IP address for the pod. So if you run the 5 nginx, load balancer will balance only one nginx, right? 1, 2, 3, 4, 5 nginx you're running, but load balancer will balance only one nginx, not all 5. So what I'm trying to say here is within a pod, it's a waste of resources to run same container, same image container 2 times. What are you going to get out of it? Nothing. It's just a waste of resources, because nginx first will run on 80 port, again nginx second you'll have to change the port 81. Not making any sense here. Load balancing will not happen. So this pod will become a waste. I mean, 4 container. This pod may not become a waste, but the 4 container which you are running remaining apart from the 1 container will become a waste. So this is not a good practice to run multiple same container with a customization, stuff like that. It's wrong. Look at this, guys. In the pod, if you have a 2 container, first container we call it main container. Okay. And the second container we call it a sidecar container. Main container, sidecar container. Okay. Here again in this pod, you have a 2 container, main container and side container. So remember, again I'm repeating, any resources allocated to the pod such as network, mount means again volumes can be attached to the pod also. I'll teach you later. And IPC, anything resources attached to the pod label, all container can access. That means sidecar will access same network, main will access same network, sidecar will access same volumes, main will access same volume mount. It's like this. Pods can scale. So once you create a pod from 1 to multiple, then earlier the 1 pod is in ready state, second pod will get into the pending stage. These are the life cycle. Guys, do you remember the containers life cycle? Anyone would like to tell me?
Yeah, it's create, start.
Yeah, create, start, stop, restart, pause, and pause,
Resume,
kill this,
pause,
that, and all, right?
unpause.
Yeah. But guys, remember, pod is not a physical entity. Pod is like a wrapper around for container. So yes, here when you talk about the pod lifecycle, there is no create or something. When you create a pod, we instantiate a pod, it'll go into the pending stage. And you see that inside a pod, there is a container which is not running right now. That's the reason it's a pending state. The moment the container inside the pod is running, then pod also will become in running state. And the pod will complete the work. It can be succeeded or failed. Then pod will get into that phase. So this is the life cycle: pending, running, succeeded, failed. So guys, here look at this. Every container of that particular pod you can run with some unique IP address within that particular pod. So let's say here main container is running with 80 and then supporting container is running with a 5000. So if you want to access this container from outside, then you have to use the pod IP address and then port number of that applications. So you can see the 80 and 5000 like this. Now how this pod communication work? Inter-pod communications from one pod to another pod. So they do have a setup pod network, just like we this setup in the Docker also, right? But this pod network is cluster wide. Mind it, cluster wide. That means all pod can communicate with all pod across the node. All the node of that particular cluster can reach out to the all pod in the cluster. That is done because of help from the kube proxy networking proxy. If you read more about it, this technology, you will understand how it works. So interpod communication, yes, through the pod network, not through node network, pod network. Okay, intrapod communication, then you have to use the IP address of the pod and port number. And intrapod communications, if you want to do, you have to use the local host. Remember, Interpod communications, pod network. Intrapod communication, localhost. Look at this image. If these two containers wants to talk to each other, they talk to each other through the localhost. Okay. So guys, what is pod? So pod is having one or more container. Pod can be your application or it can be service. Now what is service? Point to be discussed. I have not discussed so far. I'll discuss tomorrow what is service. But for time being, application. Pod is a most basic unit of work in Kubernetes. Pod is also a basic unit of scheduling in Kubernetes. This point is very interesting, guys. Please hear me out. Pods are inferal. Yes, pods are inferal. That means no pod is ever redeployed. In the container, you can do that. Let's say you created a container, you can stop the container, you can start back. But the pod is not having start-stop concept. The pod is created. Okay, think simple. Pod is created, instantiated, ready, succeeded or failed. You cannot do rework, restart the pod, something like that, or start the pod, something like that, which stop the pod. No, the pod is gone. Pod is gone. Is gone. In place of that, you will get new pod. So pod is always inferal. You should not be emotionally attached to the some pod, because once it's gone, you will not get back. In the next node also, or replacement nodes replacement also, new pod will be created, not the same pod. So if I say something like this, you will never get same pod, but similar pod, same versus similar. And then atomicity, pod is atomicity. That means they are there or not. If it is there, there. If it is not there, it's completely gone. So are you understanding, guys, these statements? What is the job of the Kubernetes? So job of the Kubernetes is to keeping your pods running. More specifically, the desired state, health, and some props and stuff like that. So this is the pod, guys. So now, did you understand what is a pod? All of you?
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.